Okay, we're going to start to look at some applications of differentiation. Okay, so applications of derivatives. Now the first thing I should just say to go on with this is there are several words and phrases that are telling you to differentiate. The first one will obviously, if something says differentiate, that one's self-explanatory. Derivative, that's asking you to differentiate. Now a new one to you is rate of change. Okay, so if a question asks you what is the rate of change, that question is telling you to differentiate. Other ones is find the gradient of the tangent. Okay, now there's more to come with this one, but that's 4 key either phrases or words that's telling you to differentiate. Alright, differentiate, find the derivative, find the rate of change, and find the gradient of the tangent. Okay, now what we're going to start to do is apply this in some real life context, and this is just going to take a wee bit of explaining and trying some examples of. Okay, so we're going to come away from just dealing with y's and x's and f of x, and we're going to be putting in some real life context, so best explained by just getting straight into an example. So let's try an example 1. Okay, example 1, let's say that f of x is equal to x to the 4, and the question is then asking us to find f dash 2. Okay, now we're kind of creeping up to a real life context here. So this one doesn't have a real life context, but it's the first step to approaching a real life context, which is to throw some numbers in. Okay, so f dash 2, well, the first thing that we do is find f dash x. That means we differentiate. So bring the power down and multiply and take 1 away from the power. So x to the 4 becomes 4x cubed. Okay, now what do I do next? Well, the question is then asking me to sub in 2 for x. So x is equal to 2. So f dash x is 4x cubed. Well, f dash 2 then is 4 lots of 2 cubed. Okay, 4 lots of 2 cubed. 2 cubed is 8, because 2 times 2 times 2 is 8, and then 8 4s are 32. The final answer 32. Okay, example 2. Okay, example 2. Find the rate of change of f of x equals x to the minus 1 at x equals 4. Now that could have been phrased like this. Find f dashed 4. So it's another way of saying the exact same thing. Find the rate of change. So what do you do? That means you do f dashed x. That means you differentiate. And then when we do f dashed x, we see what's happening at x equals 4. So it would have been the same as just saying f dash 4. So slightly different way of approaching the question in terms of how it's worded, but the same execution of the question itself. So we did it first, differentiate, bring the power down, multiply, take 1 away from the power. We've now got minus 1x to the minus 2. Okay. Now the issue at this point is we need to sub in x equals 4. So what we've not looked at doing with differentiation yet, but we're going to start to look at doing it now, is if we get our answer with a negative power, we're going to tidy that up so that you get a positive power. So the rule we'll use for that is a to the minus n equals 1 over a to the n. Now the reason being is because if I want to find out what f dashed 4 is, which I do, and I've not got a calculator for it, then I would much rather sub it into a positive power rather than a negative power. So it's dead easy. So minus x to the minus 2. What number's in front of that x there? It's 1. We're going to bring x to the minus 2 back down. This is using the reciprocal rule here. a to the minus n equals 1 over a to the n. And that's going to be minus 1 over x to the positive 2. That's f dashed x. Now I want to find f dashed 4. So what do I do then? Just sub in x equals 4 minus 1 over 4 squared. 4 squared is 16, so that's minus 1 over 16, final answer. Okay, example 3. Find the gradient of the tangent to the curve f of x equals x squared at x equals 5. Okay, now the question says find the gradient of the tangent. That means we're going to differentiate. Remember from first principles in the first look we had at differentiation, this is all about looking at gradients on curves. Okay, so the first move is to differentiate. Okay, so that's going to give me 2x, and then I want to know what's happening at x equals 5. So what do I do? I sub in 5. F dash 5 equals 2 lots of 5, and that means the answer's 10. Now, let's have a wee think. What does that answer actually mean? Well, we've got the curve y equals x squared. The curve y equals x squared is a parabola, and it looks like this. And we looked at that the very first day we looked at differentiation. Now, what does this value of 10 mean? Well, what that means is if we travel along to the x coordinate of 5, which say for example would be here, if we then travel up to the curve at that point, then the curve at that point will have a gradient which can be marked with a straight line with a tangent, and it just so happens that the gradient there is 10, and that's what differentiation is doing. It's looking at the gradient of curves at specific points. So we're looking for the gradient of the curve y equals x squared at x equals 5. So what do? You differentiate, then you move along to 5, then you move up, and whatever gradient the curve is there, that's what it is. In this case, it is x equals 10. Let's take down an example 4. Okay, example 4. Now we're going to bring in a real life context. Okay, smoke from a factory. Chimney travels route T kilometres in T hours. Calculate the speed, and then the question gives us a clue. It tells us that the speed is the rate of change, which means I need to differentiate of the smoke after 4 hours. And then it gives me a formula. The formula is the distance of the chimney smoke is given by the formula the square root of t. Let's just explain what this formula means. That means that the distance depends on the time. Right, so if you think about it, you've got a chimney and it's billowing smoke. Right, so where the smoke is and how far it travels depends on the time you're measuring it. So when time equals 0, it's just coming out the chimney. But after time equals 10 minutes, then it's going to be further on. So as the time changes, the distance changes as well, and the distance is given by the square root of the time. Okay, now I need to now find the speed. Now the question is telling me that that's the rate of change, and what does rate of change mean? That means to differentiate. But the first thing that I must do is to prepare to differentiate. Now what does that mean, getting rid of the root sign? And what's t? T is t to the 1/2, and that's just using the real indices, which is anything to the power 1/2 is the square root. So root t is equal to t to the half. I can now differentiate, bring the power down and multiply, and take 1 away from the power. Now, at that point, we've differentiated correctly, but now what I need to do is to sub in t equals 4. Now, the problem is, I don't really fancy putting that in there. That's quite difficult to calculate. So what I would prefer to do is tidy up into a positive power and go one step further. So that t to the minus half is now going to come down and become t to the positive 1/2 beside the 2. Now if I then said to you, what's 9 to the half? And I said to you, what's the square root of 9? What one would you get quicker? It would probably be that one, even though they're both the same. So anything to the power half is a square root, but I'm now better writing it with the square root because that's easy to sub into. So t to the half can now be written as the square root of t. Okay, now we want to find out what's happening after 4 hours. So I sub in that t equals 4, and that's going to be 1 over 2 lots of root 4. It's 1 over 2 times 2, and that is 1 over 4. So the distance, or rather the speed, is given by 1/4 kilometres per hour. And putting in the units gives meaning to my answer as well, which I need to do because the thing is in a real life context. Okay, example 5. Okay, example 5, we've got f of x equals 3 times root x. Okay, and the question is asking me to find the rate of change when x equals 4. Okay, so 3 root x is 3x to the half. Differentiate it, bring the power down, multiply, take 1 away from the power. 3 times a half is 3 halves, x to the minus 1 half. I then need to make a substitution, but I should do so into a positive power, and preferably with the square root sign. We should just bring that back down to the bottom, change it from minus 1 half to positive 1 half. And then finally, before I make my substitution, reintroduce the square root symbol. So it's going to be 3 over 2 lots of the square root of x. I can now investigate what's happening at x equals 4. So it's going to be f dash 4, 3 over 2 times the square root of 4. That's 3 over 2 times 2, and that is 3/4. Okay, example 6. Find the gradient of the tangent to f of x equals 5 over 4x squared, where x equals minus 10. Okay, so the first thing that I need to do is to prepare to differentiate, so I need to bring that thing up. Remember, what you absolutely do not do there is differentiate that down bottom with 8x. That's no proper maths, bring the thing up. So 5 stays with us, 4 stays with us, that comes up, changes its sign, so it's going to be 5 over 4x to the minus 2. I can now differentiate the thing, bring the power down, multiply, take 1 away from the power. Minus 2 lots of 5/4 is minus 10/4. Take 1 away from the power. Take the decision at this point, just keep an eye out for it to definitely simplify that down. That's going to be minus 5 halves x to the minus 3. Reintroduce the positive power. How do you do that? It's dead easy. You just move this back down the bottom. That's going to be minus 5 over 2x cubed. Then sub in minus 10. So it's going to be minus 5 over 2 lots of minus 10 cubed. Now, notice at no point am I needing to take out the calculator because I'm tidying up negative into positive powers. So it's minus 5 over 2 lots of minus 10 cubed. So it's minus 10 cubed. That's minus 10 times minus 10 times minus 10. So minus 10 times minus 10 is 100. Times that with minus 10, and I get minus 1,000. So now I've got minus 5 over minus 2,000. 2 negatives cancel out, and I can divide top and bottom by 5, and that will give me positive 1 over 400. Okay, example 1. find the gradient at x equals 4. And I've got f of x equals 1/3 x cubed minus 3x squared plus 12x plus 2. Okay, so the thing's ready to differentiate immediately. Bring the power down, multiply, take 1 away from the power. 3 times 1/3. That's just 1. So it's 1x squared minus 6x plus 12. The constant goes. When you find the gradient when x equals 4, sub in 4. 4 squared minus 6, lots of 4 plus 12. So that'll be 16 minus 24 plus 12. 16 minus 24 is minus 8. Minus 8 plus 12 is 4. Okay, let's try an 8th one. Right, we've got f of x equals the square root of x plus 1 over the square root of x. And we want to find f dashed 4. Okay, so the first thing that I need to do is prepare to differentiate. Let's get rid of those root signs. X to the half plus 1 over x to the half. The next move is now to split the thing into 2 terms. X to the half divided by x to the half plus 1 divided by x to the half. Don't overcomplicate this bit. Anything divided by itself is just 1. That's dead easy. Okay, so it's going to be 1. I'm going to bring that up because that's what I need to do. So it's ready to differentiate. Now it's ready to differentiate. You differentiate 1 and it goes, bring the power down, multiply it, take 1 away from the power. Okay, reintroduce the positive power, bring it back down, so it's going to be easier to sub things in. And that will be minus 1 over 2x to the 3 over 2. Now ideally at that point, and then reintroduce the square root symbol using this rule. Okay, so that down there, that up there, that's going to be minus 1 over 2 lots of the square root of x cubed. Okay, now I'm ready to sub in my number. So what was that again? 4. F dash 4 minus 1 over 2 lots of the square root. I'm putting that 2 up there just to make a point, but I don't really need to. We know that's the square root. Square root of 4 cubed minus 1 over 2 lots of, what's the square root of 4? 2. It's 2 cubed, 8. Which then gives me a final answer of minus 1 over 16. Okay, you're now going to have a go at these ones. So for each one you're going to find the gradient of the tangent at x equals 1, 2, 3, minus 1 and minus 3 for these ones. For the fourth one you'll need to expand that bracket out first before you decide to differentiate, and similar for question 5. We'll pick that up tomorrow.